All right, our fourth learning objective for the Unit 1 test is using algebraic properties of limits. All right, so this first one is a really weird question, but we went over it in class. So if I put -1 on the inside, the first thing I'm doing is figuring out the limit as f of x approaches -1, and -1 is here. And that limit looks to be about 2. All right. So then you would take that 2 and do it again. And that would make it look like the limit doesn't exist because at 2, you have this jump. All right, there's one thing to be careful with is when we look at the limit at -1, it's going to 2, but they're both coming from the bottom of 2. So really this is like numbers just less than 2, like 1.99, 1.999. And they're all numbers that are just less than 2. When I'm doing the second step, I don't look at the full limit here. I'm just looking at just the left-hand side, which is up here. So my final answer is going to be 5. All right, just because of this weird thing that's happening here. When I found out the limit at -1, they're all just under 2. So in the next step, I look at the ones just under 2, and I get 5. All right, for 14, we're looking at the left-hand limit of this piecewise. Where we're looking at numbers just to the left of 2. Those are numbers that are just less than 2. So we're kind of asking ourselves, what's happening just to the left-hand side here? So what we're going to do is just plug 2 in to that top part, and we get 7. Because when we're looking at the left-hand side of 2, those are all numbers that are less than 2. So we're just asking ourselves, what's happening on this part of the piecewise? And this one, we're using this table to help us figure this out, but our algebraic properties of limits, so we can break them up over multiplication, addition, constant multiples. So really this one limit would break up into the limit of f of x plus 3 times the limit of h of x times the limit of g of x. So really the only thing you have to know is that when you're evaluating this, you're using the right-hand side of this table instead of the left-hand side. So the limit of f of x at 2 is 4, h of x is 2, and then g of x was -6. And then if we simplify the parentheses first, it's times -6. We get 4 plus 6 is 10, times -6 is -60. All right, so using our properties of limits, we get -60. And 16 uses the same idea. This limit can separate into 2 parts. For the g part, we just have to remember to use the right-hand side of this table. For the f part, we have to use our graph. All right, so here, the limit of f at 6, well, 6 is here, and the limit that's going to be there is -1, plus 5. The limit of g at 6 is 2. All right, that bottom one there. And we get -8. Associate learning objective uses a lot of other things, but if you can figure out your limits using tables and graphs and that type of thing, you can use the algebraic properties, just remembering that this limit kind of break up into a lot of different pieces, and then you can use it individually. All right, so 1.6 is the first big one where we have to use a lot of algebra rather than just looking at graphs and tables. Just remember our tricks for algebraic manipulation. The big one is always start off by trying to plug your number in. If I try to plug -3 in, I'm going to get 0 over 0, which means I can't just plug in -3, I have to do something else. Right? And for all our rationals, when you're looking at a problem like this, generally the thing you're going to do is factor. All right, so at the top I can factor. All right, at the bottom I can factor. And the x plus 3's are going to cancel. And now that I canceled out this x plus 3 that was giving me trouble, now I can just plug in -3 and simplify -6 over -8. The negatives cancel and it becomes positive 3 over 4. So for rationals, if you can plug in the number, just plug it in. If you can't plug in the number, factor and cancel out. And this isn't in this learning objective, but these things didn't cancel out, then this would be a vertical asymptote if x plus 3 didn't cancel. But it did cancel, so then I can just plug in a number and get limit. All right, if it didn't cancel, it becomes a vertical asymptote. All right, but that's not in this learning objective. 18, all right, again, whenever you see these square roots, all right, think about the conjugate. Again, I can't just plug in 9 at the start, so I have to do something else, and the conjugate is what I do. So I multiply by the same thing, but with the plus sign. The top I'm gonna leave separate, but the things that are conjugates, I wanna actually multiply together. And when you multiply these types of things together, you get the difference of squares. So the square of the first term is just x, minus the square of the second term is 9. All right, so that's what the conjugate does. It gives me the difference of squares. That's useful because squaring a square root sends it away. All right, then I can cancel out the x minus 9s, and then I can plug in 9. I get 6. All right, so 6 is our answer for this one. All right, so when you see these square roots, think about the conjugate. All right, 19 uses this fact that sine of 2x over 2x equals 1. Right? And how do we use that in this problem? Well, we have to use some information about tangent. Tangent is sine over cosine. Oh, these should be 2x's. Just pretend like it says 2x in there. 6x, and secant is 1 over cosine. So what I want to do is I want to take a sine of 2x out of the top and a 2x out of the bottom so that I can have a sine of 2x in my problem. So it's going to be sine of x over 2x times, well, what's left on the top? Left on the top is going to be 1 over cosine x because I got rid of the sine x on the bottom, and it should all be 2x's. I keep forgetting to write the 2x's in there. I pull out the 2x, so the x is gone, and I pulled out a 2 from a 6, leaves me with a 3. And then this right-hand one, the 1 over cosines cancel, and this gives me the sine of 2x over 2x times 1 over 3. And this part we know is equal to 1. This part is just going to be 1/3, so we have 1 times 1/3. Tells us our answer is 1/3. And our last one more limit. Can't plug in 0 at the start. Whenever you see fractions, think about getting a common denominator. So to get a common denominator here, I just need to multiply this left-hand fraction by x minus 5 over x minus 5. So it's going to be x minus 5 over x times x minus 5. The second one already has the same common denominator. Now I can combine the two fractions, so I'm going to take this minus 5 and add that 5. Those are going to cancel. And once those 5's cancel, now I can cancel out these x's. And finally, I can plug in 0. I get negative 1/5 as my final answer. All right, so the next learning objective is selecting procedures for determining limits, which basically means just figuring out limits in a bunch of different contexts. All right, this one. Whenever you see an absolute value graph, I think about what happens on the negative and the positive side. So if I were to plug in like, say negative 8. Let's plug in negative 8. Negative 8 plus 7 is going to give me negative 1. On the bottom, the absolute value of negative 1 becomes 1. So by plugging in numbers just to the left of negative 7, so just to the left of negative 7, I'm going to get negative 1. Just to the right of negative 7, like negative 6, let's put it up here. Right, that'll give me 1 over the absolute value of 1, which is 1 over 1, which is 1. So if the top comes out to be negative, the bottom's positive, and I get negative 1. But if the top's positive, the bottom's also positive, and I get positive 1. So for half the values, I get positive 1. The other half of the values, I get negative 1. And there's a jump there, which means our limit's not going to exist. And this is going to happen a lot with absolute values. So if you're thinking about absolute values, a lot of times you're going to have these jump between, so at negative 7, there's a jump from the negative values to the positive values, and that'll cause your limit to not exist. right, 22 is not really a trick question, but in a sense, you might end up doing more work than you have to because you see the square root and you want to do the conjugate. But remember, the first thing you should always do with a limit is try to plug in 4. In this case, if you plug in 4, nothing bad happens. I just get 15. And if you just get a number when you plug in your limit, that's going to be the answer. And 23 is something that happens a lot on the AP exam is you don't actually have to fully solve the problem. They're just asking kind of what's a step to solving the problem. So we know for this problem, if we were trying to find the limit at 2, we would have to multiply by the conjugate. So the top is going to become, that's the conjugate, and the bottom becomes the difference of squares. And that's not equivalent to anything, but we can also factor x squared minus 4. And now these x minus 2's cancel, and we're left with x plus 2 times the square root of x plus 2, which is a. All right, so really this is kind of half of what you would have to do if you were solving the full limit, but they're kind of just making sure you know the algebraic manipulation part. And then for 24, we have to find all these different limits. So the left-hand limit, already done this in a previous learning objective, those are numbers just less than 3. So we're just going to plug in 3 into this top piece, which is 12 minus 4, which is 8. All right, so the left-hand limit is 8, because that's what's happening just to the left of 3. Just to the right of 3. Well, now if we're just to the right of 3, we're plugging in numbers that are just bigger than 3. So we're going to plug it into the bottom. We get 13. All right, so if we're plugging in numbers just bigger than 3, I only care about this bottom part of this piecewise. And what about the full limit at 3? I remember the full limit is equal to the one-sided limits if they're the same, but in this case, these are not the same, so this doesn't exist because there's a jump from 8 to 13. And lastly, f of 3 is when I plug in exactly 3, when I'm exactly equal to 3, and I get 42. All right, so just to the left of 3, I plug in the top. Just to the right of 3, I plug in to the bottom. At 3, I plug into the middle. All right, so these are a bunch of different, so this learning objective is difficult because it's a lot of different stuff in one learning objective. All right, but if you know how to evaluate limits and kind of the tricks that you'd have to do, all right, you're going to be able to do this learning objective.